This is Mrs. Anderson. I'm one of the 6th grade language arts teachers here at Glasgow, and today I'm going to be reading aloud for you your Unit 3 Nonfiction Reading Summative. First, I'll read the whole passage. Then, I will read each question and answer choice. Please feel free to play, pause, and rewind this video as needed. Along the Ring of Fire. Directions. Read the article and answer the questions that follow. Off the coast of Alaska, molten rock rises through cracks in the floor of the Pacific Ocean. This superheated material known as magma oozes like toothpaste squeezed from a tube. Stretching and erupting, the earth slowly builds a new island. Along the Pacific coast of South America, one part of the planet's surface gradually drifts toward another. Although difficult to believe, the rocky outer crust of the Earth is not solid. Rather, it's broken up into gigantic pieces called plates. Up to 250 miles thick, the plates, which float on top of a soft layer of hot rock, move at a pace of 39 hundredths to 3 94 hundredths inches per year. As the plates slide past one another, the action can sometimes result in volcanic activity. These dramatic events take place thousands of miles apart, yet they are connected. Surrounding the Pacific Ocean is a circle of volcanoes that includes more than half of the world's active volcanoes. While many are sleeping giants, others ooze lava and toss ash and rock into the air. This region is called the Ring of Fire. The Ring of Fire stretches from the west coast of South America northward to Alaska. It curves left at the Aleutian Islands and crosses the Pacific Ocean. Then it heads down the east coast of Asia toward New Zealand. Historical eruptions. Major volcanic eruptions along the Ring of Fire make history. In 1883, Krakatoa, an island volcano at the western edge of the ring, erupted in 4 explosions. The third explosion was so loud that it could be clearly heard 3,000 miles away. Krakatoa lifted a massive dust cloud nearly 50 miles into the air. For a year, that cloud covered the earth and changed the weather worldwide. Areas near the eruption remained dark from dust for days. Even 3 years later, volcanic debris in the atmosphere caused red sunsets thousands of miles away. Closer to home, Mount St. Helens, a volcano in the Cascade Range in the state of Washington, erupted in 1980. Although Mount St. Helens did not spew lava, it did cause serious damage. This eruption hurled a cloud of superheated ash, dirt, rock, and gases into the air. The ash blew eastward and was thick enough to disrupt travel. The side of the mountain fell away, causing a landslide. In 1991, Mount Pinatubo in the Philippines erupted after 600 quiet years. During 4 days in June, Pinatubo released more than 20 million tons of debris into the air, destroying many homes. Some volcanoes erupt more quietly, with lava oozing through the cracks in the Earth's surface. This type of volcano is found in Hawaii. Molten lava from a volcano such as Kilauea tends to advance slowly but still causes extensive damage. Deep beneath the surface of the ocean, the Ring of Fire is destructive, but it's constructive too. How can a volcano destroy and build at the same time? How volcanoes can be helpful. After a volcano erupts, lava flows and then hardens into rock. More lava adds another layer to the rock. Eventually, the rock builds into either a mountain or an island. Many years must pass before the harsh surface of the new island can sustain life. Over time, the hard volcanic rock crumbles into soil. Wind carries seeds that fall into the soil and take root. Islands soon become covered with dense plant life. Flowers and fruits attract birds, insects, and other animals. Island chains like Japan, New Zealand, and Hawaii form as a result of volcanic activity. Mount Fuji in Japan is one of these volcanoes, though it is not an active one. It is said to be dormant or sleeping volcano for the time being. Part of a national park has not been active in hundreds of years. Farmers even plant crops and fields along the slopes of Mount Fuji. The Ring of Fire is constructive in other ways too. Its activity not only forms islands, it also provides useful materials. Volcanic rock contains reserves of minerals commonly used in everyday life. Large deposits of aluminum, nickel, zinc, and copper are found in volcanic rock all over the world. Forms of aluminum appear on grocery store shelves as foil and cans. Nickel, zinc, and copper have dozens of uses, including the copper wire and pipes found in most homes. Volcanic activity creates some of the most magical fireworks found in nature. True, destruction lies behind the fireworks, but eventually new life rises from the ruins. If the Ring of Fire seems distant and unreal, remember that it also exists as an island awaiting new life, as a field for growing food, and as a part of the pipes that make a home. Question 1. The main idea of paragraph 5 is A. There are many effects of moving plates on the formation of volcanoes. B. Krakatoa was an eruption along the Ring of Fire that made history. C. Other areas of the planet where plates collide to form volcanoes. D. Krakatoa heaved a massive dust cloud nearly 50 miles into the air. Please pause this video until you are ready to proceed to the next question. Question 2. The map in the article shows the reader A. All the volcanoes in the world. B. Where floods are most likely to happen. C. The location of the Ring of Fire. D. The thickness of the plates. Please pause this video until you are ready to move on to question 3. Question 3. As explained in paragraph 10, island chains were formed due to A. Lava flowing and hardening into rock. B. The eruption of Mount St. Helens. C. Human interference. D. Volcanic activity. Please pause this video until you are ready to move on to question 4. Question 4. Put the following events into the correct chronological order. A. Mount Fuji, Mount Pinatubo, Krakatoa, Mount St. Helens. B. Krakatoa, Mount St. Helens, Mount Pinatubo. C. Mount St. Helens, Krakatoa, Mount Pinatubo. D. Krakatoa, Mount Fuji, Mount Pinatubo, Mount St. Helens. Please pause this video until you are ready to move on to question 5. Question 5. Directions. Drag the correct answer to the box. Complete this cause and effect chart. Cause. Lava flows and hardens into layers of rock. Effect. Clouds of debris are released into the air. Dense plant life covers the ground. Plates drift into each other. The weather is changed. An island is created. Please pause this video until you are ready to move on to question 6. Question 6. The main purpose of this article is to A. Inform readers about a group of volcanoes and the resources they provide. B. Persuade readers to research and study more about geographic wonders. C. Explain to readers where some household materials come from. D. Demonstrate to readers the ways in which lava can change landscapes. Please pause this video until you are ready to move on to question 7. Question 7. Based on the article, the reader knows this is an important detail to support the main idea. A. Off the coast of Alaska, molten rock rises through cracks in the floor of the Pacific Ocean. B. Volcanic eruption affects the culture of the Pacific. C. Volcanic rock contains reserves of minerals commonly used in everyday life. D. This eruption hurled a cloud of superheated ash, dirt, rock, and gases into the air. Please pause this video until you are ready to move on to the last question, question 8. Question 8. According to the article, which volcanic explosion caused a change in the weather for a significant period of time? A. Mount Fuji. B. Mount St. Helens. C. Mount Pinatubo. D. Krakatoa. This is the last question in your assessment. Please look over your answers carefully before submitting. See you next time.